The team at Fingers Crossed Engineering was tasked to design a strong, low-cost and low-maintenance portal frame structure within the Wollongong region, following the client's specifications. The client requested several design parameters which had to be met for the design of the structure. The parameters included a building length of 20 metres, a width of 20 metres, an eave height of 10 metres and a 6-degree pitch, with the ability to support an 8 kN per metre rafter load. The structure is to be built on a 400mm thick concrete slab with an incorporated slab edge. A minimum of 2 doors and 10 windows were also required. The roof sheeting and wall cladding was set to utilise Cliplock Classic 700 and Span Deck respectively, with both being capable of withstanding an inward-outward 1 kN per metre wind load. The structure is also to include an indoor mezzanine level at least 4 metres off the ground with at least an 8 by 5 metre area. As a team, we were required to design several necessary structural elements to complete the building. This included the sizing of columns, rafters, girts and purlins, and the correct spacing between these elements, with all values displayed within the table. It also included the satisfactory design of the mezzanine level and the size and positioning of exterior doors and windows.
To bring this portal frame from an idea to reality, it was necessary to use a program to design the structure and a program to model loadings on the structure. First, the model of the portal frame structure was created in Revit in 3 dimensions. Revit is an Autodesk design software that is useful for civil engineering design. Using Revit, the slab substructure, steel columns, rafters, purlins, and all connections and finishes were designed and are pictured here. To model loads on the structure itself, it was necessary to use the Space Gas program to model the portal in 2 dimensions. This program is designed to easily model loads, including regional wind loads on portal frame structures. The program provides a linear static load analysis as well as buckling analysis and will provide an analysis as to whether the chosen materials will be suitable for the loads applied.
As previously discussed, the preliminary design of the portal frame structure was modelled in Revit 2020. The use of this building information modelling software gave the team at Fingers Crossed Engineering the ability to model the structure with the option for realistic shading and rendering, as well as the capability of producing walkthroughs as displayed now. This allowed the model to implement all relevant engineering and architectural features, including importing structural columns, rafters, beams and slabs, sized appropriately and meeting Australian standards, as well as modelling of other features required in the design brief, such as girts, purlins, windows, doors, roof sheeting and wall cladding. This comprehensive design and modelling of the portal frame is produced in a series of drawings, including 2- and 3-dimensional views, such as floor plans, elevation views, section views, 3D views, and internal camera shots. These drawings allow the client to review the model and suggest alterations, ensuring the final structural design meets their needs and requirements.
The structural components of the design were then modelled in Space Gas, allowing for the wind load cases to be analysed. As the client requires a structure in Wollongong, Space Gas was able to generate load cases appropriate to this region, which found the preliminary column and rafter sizing from the Revit model were unsuitable for the portal frame. Space Gas was able to automatically refine the sizing to meet Australian standards. Additionally, connections including a bolted apex, a bolted end plate, and a pin base plate were added to the model. The 5 primary load cases generated by Space Gas were then extracted from the 3D model and transferred to an isolated 2D portal frame. These 5 cases were then combined to create serviceability and strength limit combination load cases, which were then applied to the portal frame. The shear force, bending moment, and deflection diagrams were then analysed for each case to provide insight to the performance of the design. The team at Fingers Crossed Engineering looks forward to continuing work with the client in the design and build of portal frame structures in the future.